Okay, so the last thing that I plan to show you is how to get a variable size matrix. So for example here in the matrix H file, all of my matrices are 10 by 10 at most. But you know, that's kind of wasteful, plus the fact that you really don't know, if 10's big enough. So what I'm going to show you how to do is to define these things as a variable. So for example, if you try to put this thing in as a variable, you're going to get errors because C needs to know how much memory to reserve for this. So we're going to use something called a Malloc, which is a memory allocation. And what I'll do is I'll show you, see if I can pull it over into the window. So I just search for Malloc. Search for Malloc online, and basically there's something called Heap Memory, H-E-A-P, Heap Memory, and it's you have your program memory, you have data that you have in there when you define variables and that sort of thing. You also have the stack, which we've talked about. And then memory that's not in any of those is called heap, and it's used for, it could be temporary storage or whatever. And Malloc is a memory allocation program, and what it will do is it goes in, the operating system does this for you, or the compiler if you have a machine control device that doesn't have an operating system. What it will do is it will go in and into the heap. It will find some free memory, and it gives you a pointer to that memory, so you can use it for your things. Now, if you try to, well, it knows it's free because nobody else is using it, so the operating system takes care of that for you. When you're finished with this heap memory, you have to free it with a command called free, which I think is down here as well. Yeah, here's an example. So you allocate memory, and it's going to be a pointer to a value. So str, for example, is a pointer. If you look right here, str is a pointer. Is a pointer to characters, and so I want 15 characters basically. And so it gives me the address of some free memory, and I'm going to set that equal to str. And so this pointer is this pointer. Okay. Now, Malloc is defined as a void pointer. In other words, it points to anything you feel like, right? And so to avoid warnings, I'm going to tell it. This right here is called a, I don't know what it's called. Anyway, what it's saying is I know what I'm doing, and I know that a Malloc is actually a pointer to a void. I don't care about that. I'm going to call it a pointer to a character. And that way the compiler says, okay, you know what you're doing. I won't complain about it. So what he's done here is he's allocated some memory. He uses the memory, right? And then when he's finished, he's going to free it up. So he says free that pointer. Notice the str is a pointer, so it says free up that memory because I'm done with it. One of the common errors that people have is they'll Malloc or allocate memory and they'll forget to free it. So if you forget to free it, that's usually they refer to that as a memory leak. What's going to happen is if you do it over and over and over again, you're going to allocate memory, not free it, allocate memory, not free it. You're just going to eat up all your memory, and it, eventually your machine crashes. So we're going to use Malloc for that. Yeah, I'm going to pause it so because some of the details get a little tiring. Okay, so I've made the first attempt at this. So if you notice what I've done in matrix H, I have changed the matrix to accept a pointer to elements rather than the actual number of values. I don't need max rows, max columns anymore, and I have this a new routine called matrix alloc, which is going to Malloc memory allocate values. And then in the multiply CPP, First thing I'm going to do is read in the number of rows and columns. Now I know how big the matrix needs to be, and then I'm going to matrix alloc the first matrix. I haven't put in the second one yet, but I'm going to do that. And then in the matrix C++ file, here's my matrix alloc. And so I'm going to send a pointer, because matrix hasn't been defined yet. I'm going to send down a pointer to the matrix. And the mat points to elements. That is a pointer to a float. So I'm going to malloc the number of variables I need. This thing here, this is a new value. I put size of float. It's kind of silly here. I mean, you probably know how big the float. Well, maybe you don't, because maybe you have a 64-bit machine and your floats are 64 bits, or maybe you got a 32-bit machine and your floats are 32 bits. So maybe you don't know what the size of a float is, and so I'm going to put in size of float. So each one needs 4 bytes, whatever it is. And then I multiply by the number of rows, number of columns, and that's how much memory I need. So I'm going to malloc that. Now when you compile this, you have some problems, right? And the problems are right here. Basically, it consists of the fact that this matrix multiply elements used to be an actual array, and now they're not. So they are giving me errors with this, because elements is now a pointer to a float. So I'm going to fix that. I'm going to pause it and get back to you. Okay, so what I've done here, you've seen these defines before, and so here's a more complex definition. I'm defining elem with 3 variables, or 3 things that get passed to it. A matrix, a row, and a column. And then let's try to tease out what's happening over here. So what it's going to do is it's going to take the matrix. So for example, here's where it's called, right here, elem. So I'm passing the first, the name of the matrix I want. So this is the first matrix. C is the row and K is the column. So those are numbers that are defined. They're going to be passed up to this elem definition. The only problem you have to watch out for this is it doesn't do type checking for you. But so you have to be careful. Don't use these too much, but they come in handy. Okay, so what it does is it's going to go in and take the matrix name, which is first, and it's going to extract the number of columns from that first matrix, multiplies by the row that you want. So these start at 0. So if you wanted element 0, 0, row would be 0, column would be 0. And that would, what I'm doing is calculating the pointer to the memory that I want. And so that's what this does. So it takes the number of columns, multiplies by the number of row that you want, and adds the column that you want. And then multiplies by the size of a float. So that's how many bytes you're going to go down into the pointer. And so what this does is this will give you the address of the location of row and column out of the thing. And then what you do is you add that number to the pointer that points to the beginning of the elements. So what this is this is the address of the location where you want the value. And then since it's the address, you give it a star and you say, I want the thing that is pointed to by this number, and it returns it to the element. So what this is going to do then is it's going to return the value that exists at row C, column K. This one is going to return the value that rests at the second matrix, row K, column D. So that's going to take those two numbers, multiply them together, and put it into the sum, add them together. What this is doing is basically the same thing. The difference, though, is that multiply is a pointer to a matrix. So that's why it's going to, I call it LMP. So here it's a matrix pointer, and you have the row and the column. And the only difference is that one uses this little arrow thing, whereas the other one uses the period. I haven't tested this. I'm going to leave that up to you, but let's try to compile it. I think I did, and there's a couple of issues. Let's see what they are. So we'll build it, and let's see what happens. So there's 4 warnings, 4 errors. Okay, I'm going to pause it till I figure this out. Okay, I forgot that the main program also indexes the values. Mainly what's happening is I'm reading this in. What I probably ought to do is I should have just put this into the matrix CPP file. So I'm going to show you what, basically what you want is these definitions. You want them to be available to the main program so that the main program can extract elements as well. You probably want to shelter that from the user because there's no way they're going to get this thing right. I mean, once you get this thing fixed, you don't want anybody messing around with it. So you don't want this to be seen by the user. So you should probably put that, like I was saying, you should have put that in there anyway. So what I'm going to do is I'm going to move this, the reading of the stuff, into the subroutine.